n-1, we're going to find the sum from n equals 1 to infinity of 2 to the power of n times 1 divided by 5 to the power of n minus 1. So basically, let's look at this. We're going to use this formula as an infinite geometric series because my r here is less than 1, absolute value of it. So let's go ahead and write this out. This is going to equal, and what I want to do is simplify this. I can write this as the sum from n equals 1 to infinity. And this 2 to the power of n, I'm going to write 2 times 2 to the power of n minus 1. Right? Because if you have 2 to the power of 1 times 2 to the power of n minus 1, you just take 2 and you add these up. So the ones would cancel. So I can rewrite that like that and then write 1 divided by 5 to the power of n minus 1. We're trying to get it to look like something easier because it has this n here. All right, so basically these have the same exponents. So I can combine these and write this as the sum from n equals 1 to infinity, 2 times 2/5 to the power of n minus 1. All right, and then I can bring out this 2 and put it in front and write this as 2 times the sum from n equals 1 to infinity of 2 divided by 5 to the power of n minus 1. Now, looking at this, since we're starting at 1, and I know here we're starting at 0, so if you add 1 here, so if this is k equals 1, you add 1 here, you have to subtract it here. So that they're equivalent if we're starting at 1. So basically, we're going to write this as 2 times. Now, your first term would be 1, because if you substitute in 1 here, that's going to be 2/5 to the 0. So that means that the first term is 2/5 to the 0 power is 1. And then you're going to take 1 minus your common ratio is 2/5. All right. This is going to equal 2 times 1 divided by 3/5. Move this 5 up here. That's going to give you 2 times 5 is 10 divided by 3. All right. That's one way to do it. Another way to do it to fix these n's is opposite way, kind of. We could write this as the sum from n equals 1 to infinity of 2 to the power of n, and then rewrite this one. And that would be 1/5 to the power of n times 1/5 to the power of negative 1. All right? And then I can combine those two, and 1/5 to the power of negative 1 equals 5. So I can bring the 5 out and write this as 5, because this equals 5 here, times the sum from n equals 1 to infinity, and put these two together, because they both are to the power of n. So I can write this as 2 divided by 5 to the power of n. Now in this case, your first term, so when n equals 1, you'll get 2/5. So your first term, using this formula again, you're going to get 5 times 2/5 divided by 1 minus 2/5. This is going to equal 5, let's put it here, 5 times 2/5 divided by, this is 3/5. This cancels out, the 5's cancel out, so you get 5 times 2/3, and that gives you 10 divided by 3. You get the same answer. So there's 2 different ways to do this problem. Thank you. Have a nice day. Bye-bye.